All right, we're gonna solve the merge intervals problem right now. So we're gonna start the timer. So given an array of intervals where intervals I, start I and I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in input. Right. So first we're gonna start off with rephrasing the problem. So our goal is to merge. So I think another way to frame it is merge a list of intervals and return the list with all merged intervals merged. So merge a list of intervals. We're going to assume we don't have our constraints right now. So what kind of questions will we ask? Questions, and put that here. So array of intervals. What does an array of intervals look like, right? Is it a class? Is it just an array of arrays? So on and so forth. So what does the input representation look like? Can I assume it's a class? Another question we can ask is, I can assume if we have an, let's say, so basically, if we have a no input, we just return an empty list, right? No input returns empty list, right? And that our intervals are just integers; they're not some sort of time. We just want to know like what is the data representation of our intervals look like. Our intervals look like, right? I don't know what other questions may be useful here. So now we're going to add our constraints. Our constraints say we're always going to get at least one, so we don't have to worry about a no input. Our intervals is an array of length 2 with a start and an end. And the time can start from 0 to, what is this, 1,000? All right, so we know we need a 1,000, so we need to deal with 1,000 arrays. So let me check. Oh, we do need to know, is our input sorted? Right, because that changes the way that we deal with this certain problem, right? Because we have a couple of ways to solve this problem. So basically, we know the input isn't sorted. So we can sort the array and merge the intervals and merge the intervals one by one. And merge the intervals one by one. We can also use a heap to accomplish the sort. Collection or a heap. And merge the intervals one by one. The logic there may be a little simpler. So what is this? We're gonna have the same runtime either way. I think the heap might be a simpler implementation because we don't need to call the sort, and then we can just worry about our heap. Okay. So what kind of data structures do we need? So we're gonna have variables. We're gonna need a heap. It's gonna be a min heap. We're gonna do a min heap that holds int, and we're going to sort by the first element in each array, which is our start time. All right, so these are variables. We're going to need a result list, an intermediate result list to hold our merged arrays, since we don't know how long the solution will be. An array list gives us a dynamic option, and then we can turn that into a 2D array at the end with a function. So we create a result list. Do we need anything else? I don't think so right now. So let's look at our steps. We're going to need to create our min heap. We'll create our min heap. 2, we're going to put all intervals in the heap. We're going to current interval. It's going to be the current intervals that we're using. Create a cur interval to hold the current interval we're attempting to merge. All right, and then how do we merge? Then we're going to iterate. We're going to iterate until the heap is empty. Iterate until the heap is empty. Then we're going to return the list as an array. Okay, so we're iterating to the heap is empty and merge according to merging logic. So our merge logic here is, when do we merge? In order for us to merge, we need to have, so merge logic is, so if we have 2 intervals that are sorted by start time, so right, so we have A start and B start, I think that might be a little too, and we're going to rewind. So in order for us to merge, we know that if our current interval end time is current interval end time is greater than or equal to the next interval's start time, we merge. Right? Current interval end time is less than. Else, and in order for us to merge, we're going to take the minimum of both start times and max of both end times. Max of both end times. And then we'll continue to next interval. Else, we add the current interval to the result list, then update the current interval to the most recent one. So let's call this one previous, because I think calling it curve. So this is going to be previous interval. And we're going to have a previous interval, and then the one that we pop off of the heap is going to be the current interval, and I think that logic makes more sense, right? And this is going to give us a solution of time O of n log n where n is the number of intervals in the array. And in order for us to add each element into the heap, it's going to take log n time. And then to merge the arrays, it's going to be log. It's also going to be the same time. So we have just a O of n log n solution where n is the length of the interval list. And then the space that we're going to have is O of n, because our heap is going to need to always carry all of the intervals, right? So let's see what that looks like, right? So it should work, right? So what does that look like? So we're going to do a dry run here. I think we should code it first. I'm going to code it first, and then I'm going to do a dry run to see if we have any logic errors, and then we can fix it if there is any, right? So we know we don't have to do any null checks. So we're going to create our heap. So a heap in Java is a priority queue. And that's going to be an int. And we're going to call that min heap. And that's going to be a new priority queue. And then the logic is going to be interval A and interval B. We're going to do an anonymous function here. And we're going to compare. So integer dot compare A0 to B0. And that's going to get us the natural order. And then we're going to do for int interval and intervals. Now we're going to do a for each statement to add all intervals into the priority queue. It's going to be pq.offer interval, right? And then we're going to do now we're going to create our previous interval. PQ it's going to be min heap.poll. I accidentally put PQ because that is the way that I always do it. So now that we got our current interval, we're going to need to create our result list equals new array list, because now we need to actually start formulating our result list. So while min heap is not empty, right? What do we need to do? So we need to find out what our current interval is. Equals so we're going to poll the heap to get our current intervals. And now we need to compare if previous interval dot one is greater than or equal to cur interval 0. We're going to need to merge, right? So cur. No, we're gonna keep previous interval, right? Previous interval 0 is equal to math.min. Previous interval 0 cur interval 0. Previous interval 1 is equal to math.max. Previous interval 1 cur interval 1, right? That's just going to compare that's going to merge the intervals. Else we're going to put previous interval into the array and update previous interval to be current interval. Right, and that should handle the logic there. And then at the end, we know we're going to have a floating interval that hasn't been added yet, so we're going to need to add result.add previous interval. And now we're going to return our result.toArray. We're going to do a new int And that's going to be result.size. And this here should give us the current solution. So what does this look like if we use these solutions, right? So let's say we're going to use this one here. We're going to dry run with the current input, which is, so our input here. So we're going to do heap. We're going to assume that we've added all the intervals into the heap now. So our heap is going to be essentially this, because it's already sorted for us, right? So our heap is just going to be, is more or less going to be represented by this here. So then previous interval. So what is, so we're going to simulate the run now. So previous interval is going to equal to current interval. We're going to need a heap. Result. So previous interval is going to start off as 1, 3. Current interval is going to start off as 2, 6 when we first pop it off. Oh, we don't need heap here. We're just going to have to just do the logic results. This is going to need a merge. So previous interval is going to become 1, 6, right? Here, previous interval is going to be 1, 6. Current interval is now going to be 8, 10. All right, and then the result here is going to be, we're going to add 1, 6 to result list. Previous interval equals current interval. Right. Now, previous interval is going to be 8, 10. And current interval is going to be 15, 18. Since we have no overlap here, again, it's going to be the same thing as the other one. So we're going to add the interval 8, 10. 8, 10 to the result list. And then previous interval is going to be current interval, right? And then our heap is empty. So at the end of, so the loop terminates. Previous interval is going to be equal to 15, 18. We're going to add it to our result list. And then we're going to return a list to the array that has 1, 6. 1, 6, 8, 10, and 15, 18. I know we need to speak about our edge cases here. So I think if we had more time and we needed to thoroughly test this, the test cases that I would provide would be an array where all intervals merge. We want to be totally disjoint array, and we want to have some mix. We want to have unsorted and sorted lists of intervals, and a single interval. I think that would thoroughly test this function here. I'm going to stop the solution here. Thank you.